Welcome to Roadmap to Residency, Evidence-Based Applications. Hello everyone. So in this video, we will be talking about some major immune responses. So let's first talk about self-tolerance. So immune tolerance is defined as a state in which the individual is incapable of developing an immune response against a specific antigen. Now, self-tolerance refers immune to lack of responsiveness to the individual's own tissue antigen. So protection from self-protectors or deletion of autoreactive clone appears to be the major mechanism of self-tolerance in T cell. So tolerance of self-reactive T cell is extremely important for prevention of autoimmune diseases. Now, in contrast to T cell tolerance, B cell tolerance is maintained largely by clonal energy. Because most self-antigen are T-dependent, autoantibody formation may be prevented by tolerance of either specific B cells or the relevant T helper cells. So the lymphocytes, either T and B, that leak through the barriers of clonal deletion are restrained by suppressor mechanisms. So the mechanism of autoimmune disease. So autoimmunity results from multiple factors, including susceptibility genes that may interfere with self-tolerance and environmental triggers that promote the lymphocyte entry into tissues, activation of lymphocytes, and tissue injury. Breakdown of one or more of the mechanism of self-tolerance can unleash an immunological attack on tissues that leads to the development of autoimmune diseases. Now, all the immunocompetent cells, genetic factors, and infectious agents are involved in mediating the tissue injury. The main is somewhat the breakdown in the self-tolerance. So the loss of self-tolerance can be either through the bypass of T helper tolerance or imbalance of T suppressor helper function. So antibody responses against most self-antigens require collaboration between hapten-specific B cells and carrier-specific T helper. Mechanism is the modification of the molecule, which can then cause cross reactions and which can then cause polyclonal lymphocyte activation. But if there is any loss of suppressor T cells function that will contribute to autoimmunity, and excessive T cell help may drive the B cells to extremely high levels of autoantibody production. So these are the two main mechanisms behind the loss of self-tolerance. Now let's talk about primary immune response and secondary immune response now. So the primary immune response is the slower, weak, IgM mediated and does not have a memory function. Whereas the secondary immune response is a strong IgG mediated and has a participation of memory cells, so that it has a memorical function. So the primary immune response, so IgM is the first antibody to appear in the primary immune response, and later there is the development of IgG antibody. So the final concentration of IgG is higher than in the primary response, and IgG appears earlier than in the primary response in case of secondary exposure. So whenever there is first exposure, there should be first development of IgM antibodies. And when the IgG antibody starts rising and gets at its peak, then the IgM falls down. Secondly, whenever there is second exposure of the same antigen, then the IgG antibody starts appearing in the blood faster than the IgM. There is also production of IgM, but due to the secondary and memory function, the IgG antibodies appears early than in the primary immune response in case of second exposure to antigen. Again, you can see here, so first exposure to antigen A, there is the IgM antibodies to IgM antibodies to A, and then there is the IgG antibodies. Again, there is antibodies to B, the antigen to antigen B, and again, the same function ensues. Let's talk about some of the difference between the primary immune response and secondary immune response. So the primary immune response is the reaction of the immune system when it contacts an antigen for the first time, whereas the secondary immune response is a reaction of the immune system when it contacts an antigen for the second and subsequent times. It appears mainly in the lymph nodes and spleen, where the secondary immune response appears mainly in the bone marrow and then in the spleen and lymph nodes. This occurs in response to the primary contact of the antigen. This occurs in response to the second and subsequent exposure to the same antigen. The antibody level reaches its peak in 7 to 10 days, whereas it takes around 3 to 5 days. There is low affinity to their antigens, affinity of antibody, whereas there is high affinity to their antigens. The responding cells are naive B cells and T cells, where the responding cells are memory B cells. So the both thymus-dependent and thymus-independent antibodies are involved in the primary immune response, whereas only thymus-dependent antibodies are involved. So the lag phase is long, that is 4 to 7 days, whereas it is short. So the types of antibodies, so a large amount of IgM and a small amount of IgG are produced, whereas in the secondary, a large amount of IgG and a small amount of IgM are produced. So amount of antibodies few, where it is 100 to 2000 times more than that in the primary response. Thank you for watching. Keep studying hard.